My name is Glenn Albert. I'm the RDI director at Exacto, and today I'm here with Mark Mahady, the president of Mahady and Associates. Thank you for joining us, Mark. Can you introduce yourself and tell us a little bit about your background and your company?
Yeah, thank you, Glenn. First of all, it's a pleasure to be with you here this morning, and I very much appreciate the opportunity to spend time with you and Exacto. Um, my name is Mark Mahady. I actually grew up in the Midwest, in Minnesota and North Dakota, and the reason I'm going to give you a little bit of background is it kind of very much has a direct influence on my company today. I started working at a golf course, Somerset Country Club, in West St. Paul, Minnesota, when I was only 13 years old. My first job was to wash and wax the shop floor for $1 an hour. And that's how I started my turfgrass science and turfgrass culture adventure. I through that experience, I really gleaned a love and a joy with the game of golf and turfgrass management. I completed a bachelor's at the University of Minnesota in agronomy. And then following that, went to Southern California, to the University of California, to work with Dr. Vic Jabot and Dr. Vic Youngner to acquire a master's in turfgrass research. After that work was completed, I worked as a staff research associate at the University of California, Riverside for 3 years. And we specialized in water conservation projects. We got a very large grant from the Southern California Metropolitan Water District. And we were, the objective of the grant was to establish ET rates, highs and minimums for both cool season and warm season grasses in Southern California. And that work is still referred to as today as baseline information on ET structures for 3 warm season grasses and 3 cool season grasses. Following that time, I was hired by the ChemLawn Services Corporation, and I moved from Southern California up to the Monterey Carmel area. And I was the Western States research scientist with responsibilities in turf and ornamental research for ChemLawn, extending from West Texas to Seattle, Washington, and from Boise, Idaho to San Diego. I worked in 12 different ChemLawn branches, and I had a field station in Salinas, California, and then cooperative research with Tom Cook at Oregon State, with, at the time, Vic Jabot and Dr. Vic Youngner at the University of California, Riverside, and also an independent researcher in the Denver market. When that position was eliminated in 1992, I started my own business, Mark Mahady and Associates. Today, about 70% of our revenue is driven through contract research completions relative to product development companies such as Exacto, such as Bayer and Syngenta and Corteva, many of the large product development companies that provide products and information and technical research to end users in the golf course, sports field, landscape. And then also in the last 5 years, both the grape industry relative to wine production of Pinot Noir and Chardonnay wine grapes. And it's really a pleasure to work in this area because of the 70% of revenue that's driven through contract research, we also do consulting in that regard. So we take the best information relative to the information that we've generated, and we provide that as a consulting package to our clients, both in the golf course and in the wine grape industry.
Got it. So your company's based in California, or you do most of your work in California today?
That's correct.
Okay.
We actually have done work all over the United States, but most of our work, really the last 7 to 8 years, has really been in California and Nevada.
Got it. It's really interesting. Thinking about the work you're talking about doing in agriculture more lately, and then comparing that with the work you've done in turf. What kind of similarities or overlaps have you seen, or differences in that work? Let's say with water management and grape vineyards compared to turf. How do you see those two different worlds?
In many cases, Glenn, I really think that there's many more similarities than there are differences. Mm-hmm. Obviously, water is a significant issue in California, not only in terms of availability, but also in terms of cost. We have golf courses that are clients of ours that spend over $1 million a year on irrigation practices relative to maintaining turf throughout the course of the year, not only for the cost of water, but also the cost of pumping water. And so that plus the fact of where we are now in our many-year drought in California, we've received over 3 inches the last 2 weeks, even here in Carmel Valley, which is a good thing. But water being a natural resource that is extremely limited really affects things agronomically, but to a great extent economically in both areas in turf and agriculture.
Got it. I was really intrigued by some research from New Mexico State a few years ago looking at subsurface drip irrigation for use in highly managed turf, and just got me thinking about what kind of technologies are mainstream in the ag space, but not yet in turf, and then vice versa. You know, things that we're doing in turf that could have applicability in ag. Any thoughts on that? Have you encountered any of those kind of overlaps?
Yeah, you know, it's interesting. Actually, in the research work that we did in the late 70s with the Metropolitan Water District, we actually had a subterranean irrigation variable in one. So we had above ground irrigation, but we also had a subterranean irrigation. So the University of California has been working on that technology for many years also. And I know that Mateo Serrano, when he was at New Mexico State, now he's a USGA, a research agronomist in irrigation, is really kind of the go-to guy in that technology. And I think as we really begin to define areas of the golf course that can receive from a practical, functional, and economic perspective of subterranean irrigation, particularly on smaller areas on tees to start, and then potentially even larger areas in fairways, tremendous levels of water savings can be achieved. In agriculture, and I'll be very, very transparent, most of my experience in California is in wine grapes. And in wine grapes, the manner in which they are irrigated is either with mini sprinklers in many cases and or drip irrigation to support the growth and development of vines. And then the other thing that's critically important is that, and I'm very much, although I've worked in grapes for the last 5 years, I consider myself really a very, very much of a novice in that regard. But I know that I have friends that are very successful wine grape growers in Napa and Sonoma that are actually looking at almost dryland summer farming in terms of grape production, not only for the quality of grape, but also for grape production. And so their concept would be is that they would use their drip irrigation systems to build soil moisture early in the spring and summer, and then really just go to a dryland farming perspective throughout the course of the summer. And that's why this conversation is important relative to the potential to inject certain products in drip irrigation systems for use for the plant as they move through high summer temperatures and high summer ET conditions.
Mm-hmm. Yeah, it makes me think about just kind of on the flip side, Exactor does a lot with weed control, and you know, some of the emerging technology in the future is targeting those applications so, you know, just to where it's needed, right? So, you know, just to where the weeds are. Or another example would be precision nitrogen fertilization, where you take you know, you take a data layer and then you apply accordingly in a precision manner, so that you apply higher rates where as needed and lower rates where you don't need it as much. And exactly. I'm thinking out loud about on the soil side, what you just referenced, you know, especially when you have those targeted irrigation systems already there, as opposed to having to maybe flood an entire field or broadcast some kind of a dry soil amendment across an entire field. You know, that precision irrigation system's already there, and so it is it's an opportunity to deliver nutrients as well as other materials that can help with irrigation or soil moisture. So
right. Interesting. And as a little bit more background, we did do one replicated field research trial in Pinot Noir with a polyacrylamide product, and also supplemented with a wetting agent product, and we saw, if I remember correctly, about 14% increase in yield production in Pinot Noir wine grapes. And the consideration there is what happens, and we've worked with Zabala Vineyards down in Soledad, and Jason Melvin is an extremely experienced vineyard manager. He has a master's in pathology from UC Davis, tremendously knowledgeable individual. And one of the things that that Jason has always mentioned is that when you have vines under drip irrigation and you go through sudden extreme heat where ET rates exceed the ability to apply adequate amounts of moisture to the plant through drip irrigation system, the real benefits of certain types of surfactants and wetting agents that are present in the soil to enhance uniformity and potentially to enhance longevity of more uniform soil moisture can be tremendously valuable during fruit set and actually just prior to harvest also.
Mm-hmm. Yeah, and another aspect of that I'm thinking of that we've been involved with is, you'd think about trying to wet a soil profile on a steep slope, and the longer you have to run that irrigation system, the more the surface layers are going to become saturated, and once those are saturated, and water is going to start running off, right? More so than moving downward in the profile, and so we've looked at projects or materials that can you stabilize that slope a little bit better, so that you can get the water to recharge down to 12 or 18 inches without running off. Otherwise, I think the applicator is stuck with the choice of pulsing the irrigation and doing several hours one day, several hours the next day. So it's complicated, right? I mean, we do research studies on flat, simplified spaces that are, really ideal. But then you get out in the field and there are hills, there are different soil textures out there in the field, and complicated irrigation systems. So it's interesting how many factors come into play.
And that's a great segue, Glenn, into our work that we've done in turfgrass management. So we've done about 5 different replicated research trials over the last 7 years with different wetting agents and soil surfactants. And one of probably the most well-known trials were replicated trials that were coordinated through the Pebble Beach Company and the USGA, United States Golf Association, in preparation for the 2018-2019 US Amateur and US Open. And the objective was to look at wetting agents and soil surfactants on the ability to enhance uniformity of soil moisture in the surface of Poania putting greens based on the USGA profile, and yet not reduce anything in terms of surface quality of the surface relative to soil volumetric moisture, relative to soil firmness or the surface of the putting surface. And then we also did interpreted analysis on the vertical movement up and down of a golf ball and the lateral movement, which would be bobble, versus the lateral movement of the golf ball. And that kind of the key take-home messages, and it gets back to the point that you made about undulating surfaces, is that through the use of wetting agents and surfactants, it really greatly enhances the re-wetting potential. After you dry a surface down in tournament preparation and you go on that surface, again, with a hand watering system, if you're preparing for even a men's championship at your private club and or a USGA event, basically what you're going to do is you're going to fill the profile with moisture prior to the event, and then you're going to hand water only with no above sprinkler irrigation through the event. And if you've generated a program concept of wetting agent applications prior that, let's say, the 4 to 8 weeks prior to the tournament, and then just prior to the first Thursday start, when you go on and you dry those surfaces down to less than 18% soil volumetric moisture, many times as low as 12%, and you go to hand water in the evenings between tournament days, the water that you apply does not to the surface is no longer hydrophobic. What happens is that with the presence of wetting agents and surfactants, it allows you to re-wet those surfaces, and the water doesn't just stand on the surface and run off, it actually penetrates the surface. And that's what we found that was really tremendously valuable in the work that we did with USGA and Pebble Beach Company. We did not influence surface firmness. So the receptive nature of golf balls, particularly wedge shots into the greens, was excellent. We saw really great, robust nature in terms of growth and development of POA. And we saw actually a reduction in bobble and lateral movement of golf balls that had been treated with wetting agents and surfactants.
Mm-hmm. Yeah, that the phrase firm and fast, that's what everybody wants. And for a tournament, that's one set of conditions. But I think people are trying to do that in normal play conditions too, right? With pressure on having high
Right.
green speeds, and yeah, and you add in the undulations, and you get things down towards the wilting point, really, really dry. You're on that razor's edge where you're going to have spots dry out faster than other spots, and then that challenge of hand watering becomes that much more challenging, right? At least at the tournament, you've got a whole crew maybe
Right.
on hand watching for it, but it's hard if you have limited labor. And so, yeah, we see that with, you can kind of make a map of the volumetric water content on a green, and you see without a wetting agent, you see that variability, really dry spots, really wet spots, and then it's on the manager to try to even that out with hand watering. But
Right.
yeah, being able to get rid of that hydrophobicity that's causing some of that variability absolutely evens things out as you dry down. So
And one of the most fascinating things for me, Glenn, too, is and I had not done a lot of wetting agent work prior to these trials.
mhm.
So we had our plots were 10 by 10, and we had 5 by 10 foot treated areas adjacent to 5 by 10 foot in plot checks, which are referred to as untreated areas. And so we followed the exact same protocols from April through the mid-June, and the golf course superintendent and his assistants were out there, all of the mowing practices, all the irrigation practices. And so during tournament week, which was the second to third week in June in that year, they would come out and hand water my Poania nursery plots. And the areas that were treated with wetting agents and surfactants with this hand watering, the water would penetrate immediately, even on a flat surface. And so if you look at the adjacent areas that were untreated, the water would literally sit on these surfaces, these flat surfaces, for about 3 to 4 minutes before they would penetrate into the soil. And if you can imagine what that would be like if you're at Pebble Beach, you've got green sizes that are less than 3,000 square feet with all these undulations. If you're a golf course superintendent, you're hand watering for a tournament, and you don't have a surfactant present in that profile, when you apply that water, it's going to roll right off this. It's going to hit that hydrophobic surface, and it's going to roll right off to a lower point on the putting surface. And that just creates obviously even more complications relative to the uniform nature of soil volumetric moisture in putting greens across the entire surface.
Mm-hmm. So I'll ask you a question. Let's pretend that I'm one of your consultant clients, golf course superintendent, and I want to try one of these tools. And there's so many options out there, right? I mean, how would you approach, what we just talked about was one study, one case study, where it's a lot of good data from it and a lot of good learnings. How do you take that and apply it to your facility, under your conditions? How would you take that from point A to Z?
Really good question. So in California, obviously, in most cases in California, we get very little rainfall from, let's say, approximately May 1st or April 15th until about Halloween. Our rainy season really extends from November until about March. So in most cases, the only applications of water is through irrigation. It's not through Mother Nature and precipitation.
Mm-hmm.
And so in most cases, when we work with clients, even in fairway areas, we highly recommend that they either inject a product into their irrigation system on a regular basis, starting early in the season, starting as early as April 15th, excuse me, and then continue that throughout all summer months. And basically what we have seen in that situation is a much greater propensity for consistent, uniform soil volumetric moisture and turf quality. And where I'm going here is that we did a replicated trial at Spanish Bay several years ago, one of the Pebble Beach courses in Pebble Beach. And we looked at a Poania fairway irrigated to 60% ET, okay, which is very low for annual bluegrass, very susceptible to heat and to salinity and to lower soil volumetric moisture. And basically what we did is we started these treatments in May, and we ran them until the end of September. And the objective was to look at whether wetting agents and certain types of soil surfactants can enhance the ability of POA quality over time, even at a very low ET rate of 60% ET. And the answer was, yes, we can. What would happen with our untreated check plots is our untreated check plots would fall below an acceptable turf quality after about three weeks of 60% ET irrigation. Whereas with the use of wetting agents and soil surfactants, we were able to extend high quality turf for a period of 7 weeks, which as a golf course superintendent means that you can run that water savings for an additional 4-week time period and while maintaining acceptable quality. And it's not only important from really an extreme perspective of going to 60% ET, but let's say hypothetically, Glenn, that you're the golf course superintendent and you know that you're going to be running into water quantity issues throughout the course of the year on your golf course. What this type of information really brings value to superintendents is that it allows you to manage water throughout the course of the year. In other words, you might consider watering at 90% ET during a much warmer period of time during August and September, but knowing that May, June, and July, you could actually water at, let's say, 65 to 70% ET, realize water savings earlier in the year, while in combination using wetting agents and surfactants to build root systems and to build robust turf, and yet also reducing the total amount of water used throughout the season and maintaining high levels of acceptable turf.
I mean, that approach, it checks so many boxes because you have, you called out just the pure supply and availability of a critical resource, right? If you don't have water, then eventually the turf's going to wilt, right? And then there's an economic piece to that, right? The cost of water and how much you can cut back on that cost by reducing the water use. Then there's the environmental piece of it where kind of back to the natural resource, right? It's more sustainable to use less water. And then I'm thinking about here, in Wisconsin where I am, we have some years that are wetter than others, and we don't have the water quantity issues like you do in California. But even so, just from a playability standpoint, I think you still want to optimize that water use, right? Because it's best for playing conditions. It's from a microclimate for disease pressure standpoint. I mean, in all these situations, all these tools, I think, that help you manage soil moisture, and wetting agents is one that we've talked about a lot, but the irrigation system optimization where you're optimizing the uniformity across the system, and soil moisture probes and things like that, I think all fit together as all different tools for the water management program. So, wetting agents have a lot of value, and they don't do that work by themselves, right? They're part of this system. It's what soil you have, it's what grass cultivar, it's when you're turning on the sprinklers, it's what kind of water you have in terms of chemical properties. So many factors, and I'd like to see more research in this area in the future. I think it's so important for all of our livelihood. And, there's a handful of people who do really good work with this, but I wish there were 3 times as many irrigation researchers as there are.
I think the other thing too, that we have seen from a very practical perspective, Glenn, in the field, particularly with fairway applications, is that, and to get back to the point that you just made, irrigation uniformity for many older golf courses is really not very good. And so if you have, even the best case scenarios today is maybe 88 to 90% in many of the newest systems, which is really very, very good. But a lot of the yield systems, we're looking at, 55 to 60%. And so when you go to golf course superintendents and you work with them and you tell them that they need to cut their water back, so if they're at 60% coefficient uniformity and you want them to go to 60% ET, what it means is that all their poorly uniformed irrigated areas are going to be subject to extreme moisture loss. And what happens is you just get these pocketed circle looks throughout the course of the golf course. What wetting agents do is they really give superintendents a very sound agronomic tool to help them enhance the performance of the water that they do use, and particularly where they don't have good irrigation uniformity across their surfaces. It allows them, with somewhat of a cushion, a valuable tool to help them get through periods of time in which they don't have adequate water supplies. Now, I grew up in the Midwest, and I know it used to rain on a fairly regular basis during the summer, thankfully. But in California, we don't have that luxury. And so, and it's not only in that situation, it's not only a situation in which you're going to have drier soil moisture. Lots of times in California, you're going to have the potential for accumulation of different types of salts. So your total EC levels, your salinity levels are going to increase, that also create less than desirable soil environments for the growth of particularly a lot of cool season grasses and even some warm season grasses.
Mm-hmm. Yeah, and even though we get way more rain here, of course, in the Midwest, but that being said, a lot of these systems are being built on coarser textured soil. So sand putting greens, of course, or sand cap fairways would be an example, but you also see, when you drive by a construction site and you look at what they're putting the turf on top of in terms of the fill materials, it's not like it's the beautiful silt loam that's been delivered across the landscape by the glaciers. It's often gravelly, and so anyways, it doesn't take long for that to dry out, is my point. And so and we always get 6 to 8 week droughts in July and August, and you see water stress a lot of years, especially on those coarser textured soils. So I think it's a problem for everybody in different degrees, right?
Very much so.
Yeah. No, that's really interesting. So I'm thinking about from a research standpoint, what do you think the future looks like? What we've talked about a lot of these nuances, but what projects would you like to see, or what questions do you still have that you hope we know the answers to in 10 years from now?
In terms of the turf areas, I think more work that could be done on injectable products to help give superintendents more flexibility so they don't have to go and spray 18 holes, rough and fairway areas. They will do that, and they do it already. But anything that would allow them to inject a product in their irrigation system that would, particularly for fairways and tees and rough areas, would allow them to reduce labor costs for applications of wetting agents and surfactants, number one. And I think that would be the primary perspective. Obviously, as turf undergoes more stress from a public relations perspective, we're going to be looking at reducing turf areas on golf courses in many cases, in fairway and rough areas. And so anything that we can do to make sure that the turf that we do have is well maintained with injectable wetting agents or surfactants that actually hold on to moisture slightly longer would be extremely valuable. And then also, even in agriculture, because of the particular vineyards that we've worked at have very coarse textured soils, as you mentioned, anything that would enhance the uniformity of moisture in the soil profile for an extended period of time, at least in our areas in California where we don't get summer precipitation, would be extremely valuable, Glenn.
I'm curious your opinion. So the idea of turf reduction and maybe reducing the amount of irrigated area, things like that. Right. Who does that fall on in terms of pushing that change? Is it the superintendent who can make the case agronomically? Is it the Greens Committee who, what would be their motivation to do that? Is it external policy? Like, kind of, what does that shift look like? How do we get that message across?
And that's a very good question. And just this Wednesday, I'll be attending a water summit up in Walnut Creek. And that water summit is being sponsored and supported by the PGA Tour, United States Golf Association, the University of California, a number of different sod producers and the like. And it's an all-day water summit. So all of the people, Dr. Jim Baird and his ace geneticist, plant breeder Marta, will be there looking at new warm season grasses, looking at reduce their performance under really extreme conditions of 30 to 40% ET, and also looking at newer cool season grasses. One of the considerations that has just come to mind by a number of other researchers that has been the support of not only looking at turfgrass systems for enhanced water use, but really replacing old varieties of cool season grasses that are in the marketplace and old warm season grasses that don't have um, the drought tolerance and the reduced water use that a lot of the new selections do. So the newest selections of warm season grasses and the newest selections of cool season grasses are ones that we should be installing and planting to replace older varieties that don't have those specific characteristics. And it may be that they don't have as extensive root systems, as many stolons, but it also may be that they just don't have the physiology to support drought resistance as many of the new varieties do.
Yeah, that's a great call out. Yeah, we often don't, it's easy to forget about the turf being one of the parts of the system that you can change, right? So
Right,
it's
right.
always, your go-to is always what inputs could I add or what things could I do to my existing system. But yeah,
Right.
the turf is definitely one that has a big impact cultivar selection. I'm thinking out loud as we're talking here. And I've seen this in the ag space and a little bit in the turf space with some companies that are looking at it. But I'm excited for the day when we're able to really easily measure soil moisture across a big area in some kind of a remote sensing way, or in a semi-remote at least. So I know there's been different, I mean, anybody could go, I guess, take a TDR probe and map the moisture of a fairway or something, but that, that takes a long time. I think people have looked at doing it with drones, doing it with ground equipment that, that can take measurements like that. I mean, I think the technology exists. Why I think it's interesting is we spend so much time focusing on, like we talked about, the coefficient of uniformity of the irrigation system. What we really care about is the uniformity of the water in the soil. That's really what we care about. So it's like an indirect,
Exactly.
I hope that if I draw these circles this way and put these tuna cans out there and collect the water and get calculate the uniformity. But I remember I worked with Dr. Doug Soldat at Wisconsin for my master's degree, and we had we're really just a demonstration, but it was a small rectangular putting green plot, slightly sloped to one corner. And when you measure the coefficient of uniformity, it was pretty good, but that corner was always really wet. And then one summer, I think for the whole summer, we turned off that head and or the one that would hit that corner the most. And the coefficient of uniformity got really bad. It was terrible. But the soil moisture uniformity, when you calculate that, it got way better. So
it's really a valuable point, Glenn, because I mean, I have a very good friend, Mike Huck, who was a USGA agronomist and was probably one of the finest turfgrass irrigation consultants in California today. And so I used to always kind of jab him a little bit because I talked to him about the same thing that you had just mentioned. Putting all these little catch cans out here is very interesting, Mike, and it'll give us some nice CU numbers. But I would rather go out with my TDR and actually measure soil moisture, because that's really what nature is telling you about how the plant is going to do. Irrigation uniformity is very important. There's no doubt about it. And the better it gets, the more that we will all benefit. But ultimately, just like you mentioned, Glenn, what's most important is how much moisture is in the soil in that particular location.
Yeah, I think you need both pieces of information, right?
Right.
Equally important. But yeah, the more we can measure something directly versus trying to estimate it. Something analogous to that on the ag side, we've done a lot of studies with water management in trees and tree crops. And again, we can measure soil moisture, but actually that's not even what we really care about. What you really care about is how much water is getting into the plant. Correct. Right. So like it's removed, right? Irrigation uniformity is one piece, a further layer down, soil moisture uniformity, but really it's about what's getting into the plant. So we put sap flow sensors with a company called Dynamax, and they can actually measure in real time how much water is going up through that trunk and being transpired. And so it was really neat just to see how those results correlated with soil moisture, and they're related, of course, right? But it really gives you a look at what that tree is doing in terms of water use. So
I've been using the Dynamax products in terms of their wet sensor for soil moisture, salinity, and temperature for about 20 years, and they're one of the they're a very, very high quality company.
Yeah, absolutely. Yeah. Oh, that's really neat. And maybe we'll get there with turf. Of course, not with Sapflow, but the work that's been done with measuring surface temperature at two different times of day, and then you can calculate the ET. So
Right.
things like that. I mean, I think there are ways that I'm excited for the day when all that background work is kind of there foundationally, and then
Right.
it all cascades into a system that we can actually, take action on, actionable recommendations from all the data. So,
And we do have a couple of golf courses that are now using several different wireless soil sensors that they will put in locations across the golf course. And they're generating data at this point. We're trying to interpret the data. One of the challenges is that based on soil textural classifications, the information that you get from certain devices may be subject to a certain degree of rather challenging interpretation. So I think getting back to the point that you make, if in terms of soil moisture mapping on a large scale with really soil classification information in tandem that you could dovetail in for more really truly valuable and viable soil moisture information relative to plant stress is really a place that we need to go to.
Something that I'll say I lose sleep over it because this is my background in what I studied for my PhD is relating to everything we're talking about is still kind of two-dimensional, right? We're talking about the turf and the surface, and that's what all these measurements are, some number of inches down. But then these soil profiles are three-dimensional, right? And they're even four-dimensional because they change over time. And so it's trying to figure that out. For example, on a putting green, everything we're doing, all of this energy and our whole careers are often spent in thinking about the top 2, 4, 6 inches. Every soil test you send, all of that is focused on that area. And yes, we can get in situ samples and sample down to the gravel layer and things like that, and that's really valuable. It's still just a snapshot in time. So I'd be excited for technologies like what is it, ground penetrating radar that can give you kind of a 3D map of things. I know a course I worked at, we kept struggling with really dry spots in these kind of illogical spots of the putting green. Like you would think it would be on the high knobs where water runs off, but it was actually drying out the most in the center where you would think, oh, water should be depositing there. Well, we measured the depth of the sand down to the gravel layer, and spec is supposed to be 12 inches, but a lot of these were 20 plus inches deep. So whatever over the years or when they were built, that happened. And so the gravel holds that water a certain number of inches above it. And if the profile's twice as deep as that, or 20 inches deep, it's that water's not in the root zone. So it's interesting. Yeah. Just knowing that, that third dimension of the depth beyond 6 inches was valuable. So I think that's also a piece of the puzzle here, and something that maybe won't be as easy to implement as the two-dimensional stuff, I'm going to call it. But yeah. And then the fourth dimension, right? It'll be great to see recommendations and research focused, I think, on the long term, because these soils form over thousands of years, and we do a 1 or 2 year study, and it's the best we can do in our lifetime, right? But it's I think the more we see longitudinal studies and recommendations that account for changes over time, like construction recommendations, they set the specs at day 0, but then what happens after year 1 and year 10 and year 30. So yeah, interesting. Those are my perspectives. Great. Well, that's really all I had to ask you. Any closing thoughts or comments, as we kind of wrap up this discussion?
I think the biggest thing, Glenn, is that all efforts to conserve water are extremely valuable, not only from wetting agents and surfactants, but selection of turf types, how things are managed, total acreage of turf in landscape areas for function and use, and place for our children to play soccer and to throw a ball around in the backyard, as well as golf courses and sports fields and professional venues. So water savings, as long as we are responsible stewards of the environment and have that perspective, I think we can continue to have great success in the areas of turfgrass culture and also agriculture.
And I just want to build on that. I think turf can be one of the leaders in water conservation in urban and suburban areas. Turf is we hear it's the number one irrigated crop of urban and suburban areas. Urbanization is increasing,
correct,
ever, right? And so I think and we know the benefits that turf brings in those areas with erosion reduction and reducing the urban heat island effect and all these positive benefits, right? Regardless of what climate environment you're in. So yeah, I think our industry could be leaders, and I think that's really exciting. Well, thank you for your time. It was great talking with you.
Thank you, Glenn. I really appreciate the time.